All right. I'm going to hold this up close, Joe, because I want to see if closed captioning can read me on this. I'm going to speak nice and slowly and clearly. Test number 4, review. Number 1, intersection of lines in 3D. Number 2, distance between skew lines. Number 3, distance from a point to a plane. Number 4, intersection of 2 planes. Number 5, intersection of 3 planes. Number 6, matrices. Number 7, embedded in the test is vector, scalar, parametric equation of a plane. All right, we'll see if the internet can read that. All right, so that's what's going to be on the test. Now, here's the thing. There are only 5 questions on the test, which means some of that stuff won't be on there. It also means number 7, there won't be a question specifically for number 7, but it means it's tied into everything else. Okay, right? Like you should be able to convert between vector and parametric and vice versa. You should really go back and forth between those 3 forms. Everything else is what we've done in the course. Intersection lines in 3D, distance between skew lines, distance from a point to a plane, intersection of 2 planes, intersection of 3 planes, matrices, and that. And that's on the test. Okay, questions you guys want to go through before I work? Joe? Okay, distance between parallel planes, so I can do one right now. Okay.
They're not parallel, then it's like distance is 0.
Okay, I'm going to be lazy here. I'm going to tell you the steps and I'm going to make an example. Here's the steps. You're going to pick a point on each plane. Then you're going to make a vector between them. And then you're going to find the magnitude of the projection of the vector on the normal.
You say pick a point, is that what we can do?
Any point, yeah, on either point, okay? So remember when we do this here, guys, and this is the same when you're finding the distance between skew lines, distance between a point and a plane. What you're going to do is you're just going to make a vector or a line between the 2 planes, then you're going to project that onto the normal, and that's going to be the distance. I can do an example right now. Nate.
Is this going on number 2?
Yes. Are you going to ignore me? Yeah?
No. Just to make sure.
Yes, this will be on. It'll be on like in whatever 4 o'clock. Okay, so do you want an example like this? I'm going to be lazy, but this is how. Oh, sorry. Go ahead. Yes. The only way it could be, they'd have to be parallel, right? That's the only way it could happen. All right. So the way it would go is this. Here's example 1.
When I'm thinking about this, I think about it in 2D, like looking at a plane.
Yeah,
For sure. Is that why?
So example 1. We're just going to say quickly, guys. Here we go. Find the distance. Okay. So those are my 2 planes. I was lazy because they're both in scalar form. I don't want to make them to you. If I were to give this question on a test, I would probably give you 3 points and make you turn it into scalar form. How can I tell that those 2 planes instantly are going to be parallel? Shalene, is that a hand? Love it. How can you tell those are parallel? Their n hat's going to be exactly the same, right? If I look at this second equation, what I'm going to do is I'm going to make this in those terms to change this one into 2x minus 3y plus 4z plus 45 equals 0. So what I'm going to do is I'm going to choose a point off each line. P1 is going to be, oh, I picked off the one, didn't I? I'm going to pick the point 1, no, negative 1, 1, 0. Now, where I got that from is I said 2 times -1 is -2, plus 3 times 1 is -3, so that turns into -5, and then -5 plus 5 is equal to 0. Point 2 then, I have to get to 45. So I'm going to call that 0, 15, 0. Okay, those are not collinear points. Okay, right? They're working that. Okay, so I have to make my vector. Vector P1, P2 is equal to, we're going to say 1, 14, 0. How I got that from, excuse me, was 0 minus -1, 15 minus 1, and then 0 minus 0. Excuse me. Now I need to find the magnitude of the projection of P1, P2 onto N. Do you guys hear that, or am I just? Okay. Okay, what's the equation for the projection of P1, P2 onto N? What's going to be, please?
X dot N, or the magnitude of X dot N.
Okay, so P1, P2 dot N.
Or just the magnitude of N.
Or magnitude N. Okay, as an aside, what does N equal here?
2, -3, 4.
Okay. So it's going to equal the magnitude of P1, P2 dot N is going to be 2 times 1. Uh-oh, this is going to work, isn't it? What happened here? Is that going to work? That's going to work, isn't it? Yeah, it works.
That's supposed to be an N.
Yeah, sorry. And that's basically the standard way to find the distance between anything. You find a point on each one, project it onto the normal, and then find the magnitude.
Why did you send the root from
Oh, it's better formed out. It's better than the numerator. So I just rationalized it, right? I just times by root 29 over.
So if people don't do that, you'll.
I'm marking for speed on this one because this test is going to be long. If there's a matrix like that, it's going to be a long test, right? Just guaranteed. Right? If you're good at matrices, it won't be a problem, but for that. Okay. The other 4 questions should be, if you did your assignment, you should look at it and say, got it, I know how to do it, pop, 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 pop. That's what it should be if you did your assignment, okay? Okay, anything else you guys want me to do here? Joe, keep going. What do you mean?
Parallel to the axis.
Parallel to the axis? You want a line parallel or plane parallel to the y-axis? Okay, so if a line is parallel to the y-axis, what is it direct? What's its direction vector going to be?
1, 0. Or no, that's right.
I want to call it 0, 1, 0. That's what I want to call it. Is that right? 0, 1, 0, Michael? So I'm going to call it then, it's going to be x, y.
That's close.
What was your joke?
What?
What was your joke?
You said something about what is 0, 1, 0. I'm like, I don't know, I don't speak binary. Like,
I didn't get it. I was thinking that when I was doing that matrix and there were ones and zeros all over the place, I was back in computer mode for a sec.
You're like, what does this mean? I'm like, I don't know.
It's in, yeah, it's, I'm such a geek, I'm not gonna hear, I'm such a geek, I'm not even gonna tell the internet how much of a geek I am. So I